In this video, I'm going to show you how to do the equivalent of this using recursive functions. Recursion is a process of making something from itself. Like in the real-world mirror example, when the mirror reflects the other mirror, it also reflects itself, which means it basically keeps going almost forever. A recursive function is basically a function that does the mirror trick. However, it doesn't quite do it as long as the mirror does it because, well, we don't want to be waiting here forever for our program to run. So instead, we provide something called a base case. This is what eventually helps stop the recursion so we can come up from air from the depths of our function. Recursion is best used for solving problems that can be broken down into repeatable small tasks. This is perfect for solving simple math, or traversing over complex data structures, or even just seeing if a number is in a sorted list. Let's make a simple recursive function that returns the factorial of the number that we give it. When you see a factorial in math, it's usually a number with an exclamation point at the end. Basically what it means is if it's a 3, it is 3 factorial, and that is equivalent to doing 3 times 2 times 1. So that just equals 6. So 3 factorial is 6. 4 factorial is 4 times 3 times 2 times 1. So we can see that 3 factorial was 6. So we just multiply 6 by 4 and we get 24. There you go. If you wanted to do something like this though, it might be a bit of a pain when you're trying to actually code it. So let's zoom in a bit here and we'll create a recursive function that can do this for us. So let's create our function. We can call it Factorial, and we'll pass in an n. Now, the first thing we're going to do is create our base case. So in this case, we're going to say if n is less than or equal to 1, then return 1. Okay, now this is where the magic happens. Now all we have to add is return n times factorial n minus 1. Now, yes, we are calling the same function from the within the function. It's like function crazy stuff is happening here. But basically what's happening is if we call this and n does not equal -1, we are then going to multiply n by whatever the result of n minus 1 is. So let's go over a simple example here. Say that we're passing our recursive function a 5. When we call it with a 5, we check if 5 is less than or equal to 1. If it's not, we return 5 times factorial 4. But because we're calling another function, that function has to run first. So we will run factorial 4. Factorial 4 will check if it's less than or equal to 1. It is not. So we return 4 times factorial 3. We're right back where we were. We have to wait for factorial 3 to finish. So we start running factorial 3. 3 is not less than or equal to 1, so we return 3 times factorial 2. Guess where we are? We are now running factorial 2. 2 is not less than or equal to 1, so we return 2 times factorial 1. And finally, we get to a point where the 1 is less than or equal to 1, so we just return the 1. Now, all we have to do is go back up and see what's been paused and waiting. So the first is 2 times 1, so we're going to return that. Then it's 3 times 2, so we return whatever 3 times 2 is. Let's do some crazy math here. It's 6. Okay, it's 6. Then we're going to do 4 times that 6, which is 24. And then finally, we get up to the very last one where it is 5 times 4, which equals 120. So if we run it, we can see we get 120. Perfect. This is basically the programming equivalent of looking at two mirrors that are facing each other. This is the first video in a series where I'm going to go over a bunch of cool things that you can do when programming. I'm going to show you how to make your code go faster using things like memoization, how to become a computer yourself and talk in binary. Maybe not talk, but understand it. I'm even going to show you how to make trees and graphs. Probably not the ones you're thinking about right now though. So smash that subscribe button if you want to learn more, and throw a comment down below if you want me to go over something specific, or just like throw an emoji or something down there because engagement. Thanks. That's all for this one. Remember, I'm Jake, you're awesome, and I'll see you in the next one. Cheers.